Alright, guys, we're going to go over the principal engineering for the semester review. We can go over all of them in this video, okay? Okay, so we'll go ahead and pull it out. Okay, we're going to go over number 1. Okay, so number 1 says in the simple gear train below, gear A and B have 10 teeth, gear C has 30. Using gear A as a driver and C as driven. So that's saying A and B, A is the one that's going, and asking what is the mechanical advantage of the system. Okay, before we begin, once again, the final will be really similar to this, so as long as you study, you should be okay. Alright, so to do this, the mechanical advantage, okay, it's MA equal to number of teeth, the driven one, divided by NN. So in this case, our M out, which is the bigger one, which is the C, and N is the A, okay? It just happens to be A and B have the same amount of teeth, so you can literally use A or B. So to solve it, 30 divided by 10, our mechanical advantage is 3. Okay? Next one. So we got this inclined plane right here. The height is 6.4 feet and the length is 26.5 feet. If you remember, the mechanical advantage of inclined plane is basically the length, the travel length, okay, over the height. So in this case, it'd be 26.5 divided by 4.6. You end up getting around 5.8. Okay, that's your mechanical advantage for number 2. Number 3, what class of lever is shown in the figure, and justify your answer. And B says how much effort force is used to balance a 100-pound load. Okay, for number 1, this is the class 2. So when class 2 is basically says that when you have a lever and the tipping point is at the end, okay, if your resistance is in the middle and the effort at the end, that's the second class. The third class is just the opposite. This is actually the R, and this is the effort force. Okay, so to solve it, so for number A is second class, and B, okay, that's to solve for how much load do you need. So to do this, you just do a proportion by you just solve it by A divided by 4, which is the resistant arm and the effort arm. Okay, so A divided by 4. We already know the load is how much? 100 pounds. Okay. Okay. One second. Okay, and the effort force is just right here. So, and basically just solve for the E. So A divided by 4 equal to 2. 100 divided by E is equal to 2. So your effort force is 50. So because this is a mechanical there's a mechanical advantage of 2, that means we actually need only 50 pounds to lift up 100 pounds. Okay, number 4. It says a screw with 20 threads per inch. Okay, so that's your P. Okay, so 1 over 20, that's your pitch, the threads per inch. Okay, it's turned by a screwdriver using handle diameter 0.6 inch. So what's some ideal mechanical advantage? To solve for the screw, the equation is circumference over the pitch. Okay, So pi d of the screwdriver, the circumference, and then the pitch. 1/20. So pi 3.14 times 0.6 inch, and on 1/20, you should getting about 37.7. Okay, number 5. Okay, number 5. As true or false, a wedge is used to move an object from lower to higher elevation. That's false, because a wedge is basically like you chopping a wood using an axe. Okay, it doesn't really necessarily move anything up and down, so it's false. Number 6, in a first class lever, the load force and effort force must act in opposite directions. That's also false. So because effort force for the first class, they're actually both going down. Okay, so they're not going opposite direction. Number 7, the simplest of 6 simple machine is D, inclined plane. And that's pretty much the easiest one. Number 8, what type of lever does the following object use? The answer is A, because here's a tipping point, here's your resistance, and the guy is trying to lift up in the middle. Okay. Number 9, how many pounds of effort force actually to lift up 60 pounds? So if you look at the picture carefully, there should be 3 wires. Okay, so really the ideal mechanical advantage, it just depends on how many wires. So in this case, since it has 3 ropes, so 60 divided by 3 equals 20. So the answer is C. So once again, lever for pulley, your mechanical advantage is all dependent how many wires, how many rope you have. Okay. Number 10, another name for an input force is effort. Okay, you're putting an effort on a force. Okay, number 11, determining mechanical advantage. So once again, like what I said earlier, it's all dependent on how many wires. If you count how many ropes it has, if it's 1, 2, 3, 4, 5, 6, 7, so the answer is C, number 7. Number 12, simple machines help us move things by changing the size or direction of the blank force. Okay? Because, for example, you have a pulley. Alright, usually, let's say you have to lift up this box, usually you have to lift it up. But when you put it on pulley, you're actually pushing down the opposite direction, right? So it changes the direction of the force. That's number 12. Number 13 is the fixed pulley is used to change the direction. Okay, that's exactly what I just talked about. So it's B. Number 14, what type of lever does the object use? The answer should be first class. Because if you draw it, okay, let's say you have this pulley, you got a force going down, and your hammer is facing down, so, and then you're pushing up. So therefore it is class B. Class 1. Number 15. What blank is the ratio between mechanical advantage and ideal mechanical advantage? And the answer is A, efficiency. Because ideal, it's not actual. So over the ratio, actual over ideal kind of gives you how efficient it is. Number 16. How many kinds of simple machine we have? And the answer is 6. Number 17. The lever is a simple machine that rotates at some angle about a pivot point, and the pivot point is also called a fulcrum. So B. The effort force is located between the load and the fulcrum, and so the answer is C. third class. So just make sure you remember. A bathtub is slanted and let water go down the drain. For this reason, this consider inclined plane. So that's how water goes down the drain. Number 20, answer is C, the turning or twisting force. That's called the torque. 21, calculate the work needed to move the cart to the inclined plane. The answer is number 21. The answer is E. So you got 50 pounds. Okay, the answer is E. Because so your car is 50 pounds, and you raising up 4 feet of height, right? So it's just 50 times 4, which is 200. So basically, where the work is being done is basically by moving the car up in 4 feet in the air. So that's how you do work. Number 22, what type of lever? That's a class 1. Class 2. So the answer is A. Basically, I'm going to draw real quick. So it's got this tipping point right here. It's going down, and your F-word is going up. So that's a class 2. Okay, that's your F force. 23. Ideal mechanical advantage of pulley system is dependent on number of support tables. So support cables. That's what we were just saying earlier. 24. Something is calculated by multiplying the force times the distance traveled, which similar to the question we just did, which is work. A ramp is number 25. Ramp is an example of inclined plane. 26. When used to pry open a can of paint, a screwdriver functions as a blank, and the answer is lever. Okay, 27. This will help you on the test. There should be questions should be just like this. So if you get stuck and get lost, how the levers should look like, different class of levers should look like. So the first class should be A, which is number B. Okay, 28. Okay, given first class of distance of 5 feet from the fulcrum and to the F-word, and a distance of 33 inch from the resistance of fulcrum, what's the maximum amount of weight that can be lifted with 25 pounds? Okay, so to do that, you just gotta find the ratio between the distance to the fulcrum of the F-word and the distance of resistance. Find the ratio. So to that. Okay, so it's first convert the unit, so 5 feet to inches, which is about 60 inch, and your distance of DR and your DE is 33. So the ratio is 60 divided by 33, and you multiply by 25. That should give the answer, which is number D. Okay, something is a mechanical device that used to change the direction and magnitude of a single applied force. The answer is D, simple machine. Okay, number 30. It's really similar to what we talked about with, so to calculate that, your answer is A. All you gotta do is 12.65 divided by 4 feet. Okay. What type of lever does the following object use? So this is a scissor. Here's a fulcrum, right? And then here's your fulcrum. You're putting a force. So within your hand, you're by putting a force on that, and then you're also putting a weight from the object that you're cutting. So your answer is class 1, which is V. Alright, 32. What is the weight resistance you could lift a first class lever if you apply 20 pounds of effort? The effort arm is 10. Resistance is 5. So 10 divided by 5 gives you 2. Resistance is always something heavier, so your answer is so resistance weight is always heavier because you want to put less effort. So 20 times 2, which is 40. That's what the resistance force is. 33. Simple machine requires an effort force that is less than the force of the loads being moved. Then the simple exhibits answer is D, mechanical advantage. Fixed point of rotation on a lever is fulcrum. C. Pulley with 3 supporting stands would require 30 pounds to reach. So how many to lift? How much weight in pounds? So 30. So this pulley has 3 ropes and only requires 30 pounds. So it means you times 3, right? So you get about 90 pounds because you want to use less force to lift something heavier. So the answer is D. 36. What type of lever does the following object use? The answer is A. So for example, that's the cart. Okay, so here's your fulcrum, your weight, that's your R, and you're putting an effort at the end. Number 37. Pulley is made out of rope or chain and blank. The answer is D, because it uses a wheel. Okay, number 4. 38. Distance between 2 adjacent threads on a screw is called the pitch. Okay. 39. Changing a rotary motion to linear motion is a function of the screw. Number 40. What's the ideal mechanical advantage of a compound machine calculated? So to solve that, first you just need to find the ideal mechanical advantage of all the simple machine individually, and then you simply just multiply the numbers together. Number 41. What's the mechanical advantage of the pulley system shown below? It's just 1 because you're actually not, because there's only 1 rope, right? You're actually pulling however much is weight, however much it weighs. Okay, 42, the last one. What is when you buy a screw like that and the label outside the package says this now? So what does that mean? What does it mean? So 7/16 means the outer diameter of the screw. Okay, the 14 is how many? Is 14 threads per inch. Okay, and the UNC stands for Unified National Course Threads. Okay. So this concludes our final review. Make sure you study, and if you just study this, it will help you tremendously on your final. Okay. Hope you have a good weekend, and you'll be ready for your final. Thank you. Bye bye.